Hello and welcome to another mini lesson about propositional logic. We just finished an example of using our laws of logic to prove that something is a tautology. We were just repeating an example from the textbook in that one. So in this example, we're going to give you a fresh example of proving that something is a tautology using our laws of logic. And this one's going to be a little bit of a longer proof. So let's just start working on it then. All right, so here is our statement that we are going to prove is a tautology. Not P and P or Q implies Q is what we're going to say is a tautology, and we have to prove using only our laws of logic that this is the case. Now this is one that you could also do using a truth table, but we're not going to do that here. All right, so let's just get started. So the first thing that we have is we have an implication arrow. We have a conditional arrow. Most of our laws don't allow conditional arrows, so the best thing to do is to start off by reducing any conditionals to other operators. So let's go up and look at our conditional laws and decide which one we're going to use. So the last time we did a proof, we started out by using this conditional law. I think this time we're going to start off by using this one, just to, try out something new. All right, so P then Q switches to not P and not Q. All right, so let's look at our example here. We have P, this whole thing here is our P statement, then Q. So we're going to switch this to not, and then our P statement, whoop. There's our P statement, and not Q. And this is our complement law. Right, so we've taken Q, made it not, we've taken this, turned it into and we've taken our P statement, left it the way that it is, and then we've negated the whole thing, which is what the complement law tells us to do. All right. So our next step is going to be to break up this statement so that it's a little bit simpler. So when we have one thing and then two things in parentheses with an or, the thing that you should think of first are these distributive properties right here, right? So we have one thing and then two things linked by an or, right? So we're thinking about this property. We might use it, we might not. In this case, we are going to use it, and so we have to be careful about how we break this up. This is a longer example, and so the parentheses are going to get confusing, as well as the ordering of everything and where the negation is. And so this is an example that's going to help you keep track of those. So we keep our not out in front here. And then we have, here's our P statement, right? So we say P and Q. So P and Q. So not P and P, or, right? Yeah, or, right? And then we say P and R. So here's our P statement and our R statement. So we have not P and Q. All right, and then we just leave the rest of our statement over here. And we know this by the distributive property. Hurrah, the distributive property. Look at this, we have not P and P together. If we look at this complement law, which deals with not P and P, it's supposed to be P and not P. So really we should apply the associative property before we can reduce this. Or not the associative property, the commutative property, right? We should move things around before we can apply this law, right? So we're going to say P and not P, or not P and Q and not Q by the commutative property. All right, and then we move on to step 5, where we can reduce this. This whole statement is equivalent to truth, or to falsity, right? Because it's P and not true, right? So not false, or not P and Q and not Q. Now again, I should apply the commutative property here to switch these around. So we're going to do that. 6 takes not P and Q, or false and not Q. Oh, we didn't say here that we used the complement. And here we're using commutative again. And this statement, we can go up here and use our domination, or our identity properties here. Yes, we're using identity, right? So P or false, which is what we have. We have a statement or false, is equivalent to P. So we can just get rid of this or false. And we have not P and Q and not Q by the identity property. Look at that. Woohoo! Look at that. So great. So great. Okay. We're going to move, all right. So now we can use our associative prop. Oh, this is all negated. Oh no. Yeah, this is right. This is right. This is right. Yeah. No, the whole thing is negated. See, even I'm losing track of my parentheses here. This whole thing is negated, right? All right. So now we're going to use our associative property because we want to get Q and not Q together. We definitely want to do that because that's a lovely thing we can do, right? All right. So not P and Q and not Q, right? Associative lets us move our parentheses around. Associative property. All right, so now we would like to just cancel this out, but we're going to want to move some things around too. So let's cancel this out first, right? Q and not Q by our complement laws is false, right? So not P. Oh, actually, we're going to do this a little bit differently. All right, so before we cancel this out, we're going to deal with this negation on the outside, which is tricky to deal with once we have false here, right? So we're going to deal with this negation outside. So when we're trying to move negation outside inside parentheses, we want to use these De Morgan's laws, right? De Morgan's laws is usually what we do to move negation inside things. So here we have negation with an and statement. So we're going to use the second of De Morgan's laws, negation over and. So when we do this, we negate both things inside and switch it to or, right? So we take, we're going to have not P, right? Not P, or not P and not Q. Right? That's De Morgan. And now we can simplify this using the double complement law to P or not P and not Q by double complement that's the name for this law right here, not P is equivalent to P, right? And now we want to move this negation inside too, right? Because we don't like this kind of negation. It makes things tricky. So we're going to switch this to P or, and then we look up at our De Morgan's laws, right? So we're moving it over and, right? So De Morgan over and. We're going to negate these two things and switch it to or, right? So this becomes not P or not Q. Or this is supposed to be Q. Oh no, we messed it all up all the way up to here. This was just a typo. This is a Q, right? So yeah. And this is by De Morgan, right? We can simplify this again using the double complement. See, this is a lot of just sort of messing with the way that we write our symbols, right? So not Q or Q by the double complement. And then when we cancel these out, when we deal with these kinds of complement laws, we have to have the true one first. So we're going to use our commutative property again. And now we can go up and look at our complement rules. So P or not P is always true, right? So that's something we can do. We can say P or true by the complement law. And finally, we can look up at our domination properties. Whenever we have P or true, that's equivalent to truth, and so we can say that the whole thing is true by the domination property, and that therefore QED, we have proved that this is a tautology, right? So in this proof was a lot more finicky than the last one because we kept having to reorder things and deal with our parentheses, right? And so this is what mostly what these kinds of proofs end up being, is how do you move around the parentheses. So be careful when you're doing proofs on your homework that you have all the properties in the right order before you use them, and that you have everything in the right parentheses, and that your symbols are the right way up and all that stuff. But this is how you do a proof like this.